Okay, there's one more little piece of relative motion. I don't have a question typed up. I'm just going to make it up and we'll kind of solve it together. Well, I'll solve it, talk you through it kind of on the fly. Here's a scenario. Let's say Waterloo is here. If you were to go straight south of Waterloo, almost exactly straight south of Waterloo, there's a town called Pittsburgh. You can double check on Google Maps or something, but Pittsburgh is pretty much exactly 340 kilometers south of where Waterloo is. Let's say I want to fly from Waterloo to Pittsburgh, and I have a plane. And let's say that the plane's velocity relative to air is, I'm going to make up a number so it's kind of clean. Let's say that it's 170 kilometers per hour. If there was no wind, then we can almost in our head figure out how long it would take my plane to fly from Waterloo to Pittsburgh. The distance is 340 kilometers. The plane is moving at a speed of, I guess I should be saying the displacement is 340 kilometers south. The plane's flying at a rate or a velocity of 170 kilometers per hour, also south. We're trying to find time. The connection between these three things is speed is always distance over time. That's kind of, if we haven't talked about it yet, that's kind of the definition of velocity. We can go one step further then and say 170 equals 340 over, I don't know. If we do a little math, the numbers are clean, I hope, unless I'm doing math wrong in my head. It's going to take us 2 hours. In physics world, for now, we got to keep things simple. We're going to pretend that the plane just always flies at 170, so it takes off at 170, goes through the air at 170, lands at 170. If we make that simple assumption, then it's going to take us 2 hours for the plane to fly those 340 kilometers. But now we're going to play the what if game. What if on the day of the flight, when I want to go to Pittsburgh, what if there's a wind? Let's say the velocity of the wind is 60 kilometers per hour. And we're going to say that it's pushing us straight to the east. This is going to cause a problem. If we don't do something, if our pilot doesn't do something, if we just point our nose straight south, if the plane just points as 170 kilometers per hour straight south, then the wind is going to push it to the east, not really to scale, but let's say the 60 goes down there. The plane is going to follow this path, the hypotenuse. In the 2D questions we've done so far, we've found the hypotenuse. In this particular example, though, that'd be a problem. If we follow that hypotenuse, we're not going to end up in Pittsburgh. Pittsburgh is somewhere down here. We're not going to end up in Pittsburgh. We're going to end up somewhere east of Pittsburgh. How far east, we'd have to do the math to figure out. It's not tricky math, but we'd end up over here somewhere. We wouldn't get to Pittsburgh at all. So our last little wrinkle of relative motion is, what if I don't want to get pushed off because of the wind? What if I want to end up flying straight east? Sort of by logic, if the wind is pushing our plane to the east, what does the plane have to do to fight that? Which way does the plane have to angle a little bit? So not really with math, just sort of conceptually, if I want my plane to fly straight south, but the stupid wind is pushing it to the east, then my plane has to angle to the west. So in this case, when the plane corrects for the wind, its velocity becomes the hypotenuse. It's got to angle a little bit to the west so that when we consider the east, those two combine to make a triangle where that unknown side isn't our hypotenuse this time. This time our unknown side is there. And because of vectors, we need to know a direction, or we might want to know a direction, we need to know that side right there. So zooming out a little bit. If there was no wind, no problem. Just point the plane south, plane's going to end up going straight south. If there is a wind, if you don't do anything, then you get kind of the red triangle. and you get pushed to the east, which may be fine, but it's a different flight than what we may have been expecting. If we know there's a wind and we don't want the wind to push off course, we always angle into the wind. So in this case, we'd have to angle our plane south and a little bit to the west to make sure we end up following our straight south path. I'm going to pause there, then restart, and we'll do the math.